This is Joel, and I was just exploring the service provider segment over the weekend, right? Trying out various MPLS segment routing configurations and features, and I was a bit rusty. It's been some time since I played around with iOS XR, right? So I thought I'll just make a quick video on ISS in iOS XR, right? And probably in the coming future, I might also do some other features like MPLS and segment routing and all of that in iOS XR, right? So yeah, so this is going to be a quick video. I'm gonna I already have the configurations ready, so I'll just show you how do you actually configure and how do you make sense of some of the tables of show ISS, and how do you make sense of the neighborships, the adjacencies, the concept of area, and so on, right? So it's going to be a pretty quick video probably, but also it's going to have a lot of information. So yeah. All right, so that being said, in this video we are not going to be using we are going to be only configuring the first four routers here, right? On the left hand side you've got S1, S2, L3 and L4, right? All the subnets are mentioned here, right, for you to replicate the lab if needed. And the P5, P6, P7 and the P8, these routers are already configured, and at the same time we won't be using them in this video, right, because we are just concentrating on the ISS part. All right, so coming to ISS, I mean, the technology wise it remains the same, right? You can go back to my channel, you'll see a lot of content on ISS which I've already done, mainly on the iOS part, and the concepts are almost the concepts are still the same. It's what the configuration where it changes a bit, because iOS XR you have a slightly different way of configuring stuff, right? All right, so that being said, let's start with I think the configurations. So we are on these are my routers, right? I'm using XRV, so if I do show version over here, you can see I'm running 631, right? And it's an XRV device, right? You could probably do this on an actual physical box as well if you are testing over there, right? So okay, so let's start. So what do we do first? First we will go and configure the basic iOS XR, right? Basic ISS part on my four devices, S1, S2, L3 and L4, right? And let's look at and from there we will tinker with the configurations and do much more fun stuff, right? So let's start with the S1. Now before doing that, let's look at the interfaces. So IP interface brief, you can see we've got the interfaces running. We've got a loopback interface, and then we've got some interfaces running towards so this one is so the IP address naming is this way, right? The first octet tells one of the device, the second octet also is basically representing the other device. So here this is the interface which is connecting S1 to P5, so that's why it is 1 and 5 here. So this one is connecting S1 to L3, this is connecting S1 to L4, right? So that's how the IP addresses are named. So yeah, so you can see the IP address configuration is already done, so we are ready to go and dump our ISS part here, right? So let me just grab it from here and let me explain to you what I'm actually doing, right? There you go. So pretty simple. So we've got the router ISS lab, you can give it's any user defined word. The interesting thing is the net ID. Net ID in ISS is similar to like something like a router ID, right? And again, this all goes back to the fact that ISS was not actually written for IP, right? It was written for CLNS or CLNP protocol, connectionless. That's an old protocol before IP, right? And so their whole nomenclature is slightly different from your traditional protocols. So the first octet here is going to be 49 and the last octet is going to be 0. That's going to be always same for IPv4 ISS, right? Wherever you configure this net ID, you have to retain that same, the 49, and so this is literally the AFI value and this is the cell value, right? We'll not get into much of that, but for time being, just remember that they are going to remain the same irrespective on any device. What changes is basically the second octet and this section. So second octet represents the area, right? So right now I'm putting my S1 in area 1, and that's what you need to take away from that. And the third piece which I showed here is basically the system ID. So this is the system ID for S1. Similarly, system ID for S2 is going to be different, right? So area is done, system ID is done, and then you're defining the address family, right? Which is IPv4. Metric style is wide. Again, this is because in the olden ISIS implementation, they used to have a smaller metric, right? It used to be, I think, the interface metric used to be between 1 and 63, and the network metric used to be between 1 and 1023, I guess. But over years they have realized that having such small values for metrics is not sufficient, so they have increased the value to, I think, 24-bit and 32-bit respectively. So as a result of that, for selecting that, you need to mention metric style wide, right? Maybe I'm not sure. I have a guess that I think if you don't mention this, it will default back to the old metric. So better mention this so that you use the newer metric and the newer values. The rest is pretty straightforward. So you've got the loopback interface, the three interfaces, 0, 0, 0, 1 and 0, 2. If you look at the diagram, we've got the 0, 0 connecting towards P5, 0, 1 is towards L3, and 0, 2 is connecting towards L4, right? So all those three interfaces, we've got ISIS enabled, right? So what else are we doing? So something interesting here, you can see towards P5 we have point-to-point configured, and whereas for the rest of the two we don't have anything configured. And I'll touch back on this particular point later, but just observe that, right? So over one interface it's point-to-point, whereas the rest of the two interfaces, so these are the two interfaces which are connecting to L3 and L4. So you can see there is no point-to-point, which means it is broadcast segments. And loopback, you see, it is very common to make it as a passive interface, right? Because we know for sure that this particular interface, should be advertised in ISIS, but at the same time it doesn't really need the ISIS hello packets and basically all the signaling, right? So by making it passive, we are reducing the churn, right? So we are preventing all the signaling on this particular interface. The other interesting thing you need to notice is the circuit type, right? L2 only. So in ISIS, remember, you have two different types of adjacencies. Either it is L1 or L2 or L1 and L2, right? Actually, so in that case it's three adjacencies, I guess. So for now you can see all of them are L2, right? So I'm starting with L2, right? Just remember that a L2 device can form neighborship with another L2 device, right? A L1 can form with another L1, but you can't cross or you can't mix them. You can't form neighborship between a L1 device and a L2 device, right? So yeah. So that's mainly it. So that's literally the configuration going on my S1, right? So let's, and in iOS XR, you need to, for having that configuration, for affecting that configuration, you need to commit it. So that's how you commit it. So that's S1. Let's quickly dump S2 as well, because that's very much same as what we did. So let's log into that box. I think it's disconnected, so let's try to log in again. All right, there you go. Cisco conf mode, right? So right now we don't have any ISIS. I'm going to dump. Same thing, only the difference is you can see here the area I'm retaining same, but system ID I'm changing. The system ID now is, instead of 001, I'm making 002. The rest of the stuff remains the same, right? And this is the beauty of why I have used symmetrical interfaces. You see 0102, 0102. So because I've used symmetrical interfaces, it's easier for me to use the same configuration which I did earlier. Did something wrong. That's because that router did not go properly. Okay, let's put it again. All right, so that should be good. Let's commit this one, right? So we are done on S1 and S2, right? Now the next is we need to configure what on L3 and L4, right? Which are those two devices? So we are done with the spines here. Let's go and configure our leaves, right? Right now we will not have any ISIS neighbors because S1 and S2 are not directly connected, right? So we need really L3 and L4 for anything to be shown, right? So let's do that. So let's just disconnect this guy. Let's dump in the configs again, right? Pretty straightforward. Let's go Cisco, right? So L3. Okay, so let me grab it here. conf t, and what else? So we've got the differences that we are again changing the system ID to 3. You can see because it's a very basic configuration, I'm keeping all my devices, all my 4 devices in the same area, right, which is area 1. The rest is very similar to what I have explained before, right? The loopback interface is level 2, and the rest of the physical interfaces, all of them are in level 2, right? Pretty straightforward. So let's paste that, right? And let's commit this one. So there you go. So we are done with L3, and let's also quickly wrap up L4, right? Because that's the final piece. Very similar to what we did till now, right? On L3, very similar to that. So we can, I think it should be pretty simple. So we'll do Cisco conf t, and there you go. So we've got router as. The only difference is we are making this as so this is 49, right? This is the area and this is system ID. Only that we are changing. The rest is retained. Sweet, right? Good. So that's done. So we're done with basic configurations. Now let's try to explore a bit. So we are on S1, right? Let's clear the screen a little bit probably. Let's do show IOS neighbors. What are we expecting? S1, it should have neighborships with L3 and L4, right? Because those are the 2 directly connected guys here. So let's see if we are right. Yes, we are right. Yeah, L3 and L4 and P5. But like I said, we are not going to be configuring P5, which I have already configured before. So that's why you are basically seeing this. But what is important for us is these 2, right? And observe that the type over here is L2, because we have used the adjacency which is L2 type adjacency. If you when you're configuring, if you use the L1, then that would change and appear as L1 over here. All right, next. So once we are done with that, we can also probably check the routing tables. Let's check the routing tables. So we'll do show route. There are a lot of routes here. Okay, so let's observe, or let's concentrate on the ones which are very important for us. Like I said, forget about everything which starts from 5, 6, 7, 8, right? So these are all the ones which I've already configured, which is basically arising from this section of the network, right? So forget those. Let's just concentrate probably on this is wait, where is that? Yeah, this one, 3.3.3. So that is coming from L3. 4.4.4. See, that is coming from where? L4, right? And you can see 2.2.2, that is coming from where? That is coming from S2, right? So from the topology, right, what is happening is S1 is getting the routes from L3, L4 and S2, and obviously it is getting from this side of the section, but let's not concentrate much on that for now, right? So that's literally the routes, right? And you will basically see the same thing on, if I get into, I don't know, maybe this guy, if I do show route, there you go, right? So you are getting 1 over here, and you are getting, because this guy is 2, so he will be getting 3 and 4 as well, right? So pretty simple. We have not done anything complicated yet. What we have done is we have put in the basic ISIS configuration. We have enabled ISIS on all the interfaces, and we have put all of the guys in what? Area 1. So all the interfaces are in area 1, and all of the neighborships are L2 neighborships. All right. So now, just like OSPF, right? OSPF has a LSP database, because you know OSPF and ISS are linked state routing protocols, right? So they retain the complete state of the whole network, right? Unlike something like AHRP or RIP, right? So they, like I said, they have this database where they maintain all the adjacencies. Now we talked about there are 2 types of adjacencies, level 1 and level 2. So if you have both of them enabled, and that is also a possible configuration, if you have both of them enabled, then it will have LSPs for both the databases, right, or both the adjacencies in its database, right? So before that, let's probably do, where am I? I'm on R2. Probably let's go back to S1. Let's see if we can see the host names, right? So do show ISIS host names. Yeah, there you go. So all of this is perfect. So we are able to see, you can see this is the system ID, and you can see S1 S2, L3, also L4 and so on. So that's good. Now the database which I was talking about, this is how you can see them, right? Do show ISIS database. And there you go. So this is basically telling me all the information which I'm getting from rest of the devices in my domain, right, or in my area, right? So I'm on S1 and you can see I'm getting information from S2, I'm getting information from L3, and interestingly there are 3 lines, 3 rows allocated for L3, right? So it appears to me that some devices are talking more, right, or some devices there are more LSPs. So these are nothing but the LSPs, right? Link state PDOs. Just like in OSPF we call it as link state advertisements, right? Link state LSAs, right? We've got that so many different types of LSAs, right? Type 1, type 2 and so on. The good thing about ISIS is we don't have different types, so many types of LSAs. This is literally the LSAs, and you identify by using something called as LSP ID, and that's what you see on the top here. Alright, so that being said, so right now from this I can make out that this is S1, this is my own LSA obviously because I'm on S1, but I'm getting information from S2, then L3, L4, P5, P6, P7, right? Because I have ISIS going from end to end. So you see all the the link state PDUs are seen in my database. Now this brings a very important question here. So you might be asking, why do I have 3 rows for L3, 3 rows for L4, whereas as for S2 I have just 1 row, right? So that has to do something with what we call as so ISIS operates in 2 modes, right? We can call it that way. One is the point-to-point mode and the other one is the broadcast mode, right? So in a point-to-point mode, right, or let's talk about the broadcast mode, it operates very similar to our OSPF, right? Remember we have the designated router and all of that. So when you have designated router, it works slightly differently, which we will cover in the next section. But before that, let's talk a little more on the point-to-point part, right? And I'll show you, or I'll prove it to you. What I'm going to do is, right now my connectivity from S1 and S2 towards L3 and L4, it is not point-to-point, right? And we will now go ahead and convert it and make it point-to-point, right? And we'll see the change, we'll see the difference in this, right, in this output. Okay, cool. So let's get about doing that. So what we'll do is alright, so we'll grab all these links, which is 00, 01, 02 on my S1, S2 as well as on L3, L4, and let's just convert them to point in one single shot, right? So pretty straightforward. What we'll do is, so we'll go inside, we are inside S1 right now. So let's drop this. You see, this is very simple. You just call the interface name and you say point to point. So we're basically converting them to point right now. So let's put that, commit, quickly do that on S2 and commit, and the other 2 guys as well, which is L3, commit, and the last one is L4. Sweet. So now that we have committed, let's go back and check the difference in the output. So this is what we saw earlier. Let's run the same thing, right? So now you can see that okay, probably for an actual difference you'll have to wait for, I think, 20 minutes, I guess, because that's amount of time the old adjacencies or old LSPs are retained in the database. But you can see the difference here, right? You can see already for this one, you can see the countdown is already started, these 1, 2, 3, 4. So what has happened is now the L3 and L4 adjacencies, we have converted them from what? From broadcast from the broadcast mode to point mode, right? Because we went and converted all these interfaces to point. You can see that the adjacencies has converted from broadcast to point. So if you leave for another 15-20 minutes, when we come back, right, I mean, if we retain this like this, and if you check this back after say 15-20, I think after 20 minutes, you would no longer see these entries, right? And we'll talk about these entries in the very next use case. But yeah, that's how you figure out. So that if you're running if a particular link is running in a broadcast mode, right, or in a point-to-point mode. All right, cool. So next, further, we can also, the same output will be seen on other devices as well. Further, if you want more details, you can run something like this. You can do show ISS database. You can pick one of this guy. In our case, let's pick the first one here, right, which is my LSP or my link state PDU, right, and you can do a detail and you'll basically get all the information about it, right. So you can see here the networks. This is 1.1, which is connected to me, 1.3, 1.4, 1.5. All these are networks which are connected to me, and that is basically nothing but advertised inside, you know, your LSP. So LSPs are nothing but, like I said, they are basically those just like your LSAs in OSPF, right? They are exchanged in your network. In case of point-to-point, obviously there is no question of multicast because there are going to be only two devices, so they're going to exchange among themselves and make sure that they have the latest LSPs in their databases, right? So that's interesting. Cool. So now let's go about exploring that use case which I was telling about broadcast mode, right? We just explored the point-to-point mode, and we saw that you know, there was some extra LSPs getting created, and as soon as we switched it to point-to-point, those LSPs are getting deleted, right? So what we'll do next is, let's go about alright, so to explore next, what we'll do is, let's do something fun here. So I have created a broadcast network here, and let me just probably use the diagram to explain that. So let's use this color. Yeah, so what I've done is, if you see, there is a network going here, there is a link here, there is a link going here, and then there is a link going here, right? So all of these three links, they are, you know, in this particular network, which is 1.2.5.0/24, right? So you can see that's the network, and that's the network in which, you know, these three links are present, right? So what we will do is, now we will right now I have shut down all the interfaces, this and this and this, right? All the three interfaces are shut, but now I'm going to unshut them, and I'm going to put them in ISIS, right? Enable them for ISIS, and we'll start seeing how ISIS operates in a broadcast mode, right? And because all the other interfaces over here, they are all, you know, all of this we have converted to point-to-point, right? But let's see how, you know, the LSPs and how the LSPs change in the, you know, ISIS database when we do this, right? So let's do that. So for that, let's come back to, we'll have to do the changes on S1, S2 and P5, right, if I'm not wrong. So let's go to S1 first, and let's drop this config, right? So there you go. So what I'm doing is, I'm making the interface no shut, right? I'm no shutting it, and I'm going inside ISIS, and I'm enabling that interface for ISIS. I'm enabling the level 2, right, adjacency, and I'm doing a no shut over there, right? So that should be, I think that no shut was probably not needed. My bad. So it's actually not needed. Anyway, so let's go and paste it, right? And let's probably commit this one, right? The same thing actually has to go on S2 as well. Let's do that. And the other guy is your P5. So let's go to P5 as well. Disconnect and connect it again. Cisco, right? So there you go. So let's do the same thing and commit. Sweet. So that looks good. And so now what we'll do is, let's observe first, has the neighborship formed? So let's go to this guy, probably on S1, and let's check, right? So let's see, where is it? Give me a second. All right, so I was just waiting for the S2 to appear here as well, but yeah, it took a bit of time, but yeah, it's good. So you can see what we just now did, right? We kind of enabled, this is a broadcast kind of a segment here, because we have three links which are connecting up to the same switch, and we enabled ISIS in that segment, and you can see that right now if I do show IOS as neighbors on say S1, it tells me that S2 and P5, right? So you can see the same SPNA number here. So these three devices, S1, S2 and P5, they are in the same, broadcast segment, right? And that is visible here. It's still L2, right? We can make it L1 if you want, but right now it is L2. Right, so that's the output in the show IOS as neighbors, and you will basically see the same thing if I run this on, I don't know, maybe S2 as well. Right, there you go. So you get the same thing as well, right? So now how let's look at the database, because that's where it gets interesting. So if I do show IOS database, and you see the difference here for which segment. So forget about this L3 and L4, because like I said, it's going to time out, and after probably 15-20 minutes, maybe as we progress through this video, we will no longer see this multiple entries for L3 and L4. But let's just talk about S1, S2 and P5, right? So you see S1 and S2 have single entries, but for P5, looks like there are two entries here, right? So from this we get to know that among S1, S2 and P5 in that segment, P5 is the designated router, right? Just like you have designated router in OSPF, here it is actually called as DIS to be specific, right? So it's called DIS, and that's nothing but the designated intermediate system, right? Now let's talk a little bit about why do you have these two entries. So how this really works is, if you go back to the diagram here, in a broadcast ISIS mode, right? So all the three routers, S1, S2 and P5, all of them will be sending their LSPs, right, link state packets. So they will be sending it in this way. Let's use the color. Give me a second. Yeah. So that one, yeah. So all the three guys, will be sending the, LSPs in this direction, right? And obviously it will get flooded. So whatever P5 sends, it will be coming inside like this to the other two routers, and whatever these guys send, it will be flooded to the other routers. But in ISIS, the problem is there is no acknowledgement. So S1 will really not know if whatever he sent, was received by P5, right, or vice versa. So there is no acknowledgement as such, right? And the other thing is, there's other thing which is this can create a lot of neighborships, right? Right now, if I don't have the concept of designated routers, then S1 will have to form neighborship with S2, and S1 will have to form neighborship with P5, and P5 will have to form neighborship with the S2 as well. So, and then this becomes very big, right? When the number of routers in the segment increases. Right now we just have 3, but as and more increases, right, we are going to have a lot of trouble. Like for example, if there are 4 routers, we are going to have I think 6 neighborships or 6 adjacencies, right? So this is this doesn't really scale well, right? And it is going to create a lot of traffic, a lot of control traffic flowing around, a lot of LSPs flowing around. So that's where the concept of this designated intermediate system comes into play, where one of these 3 routers, we just cleared that. So one of these 3 routers, in our case, like we saw from the output, looks like P5 has taken the role of a designated intermediate system, right? So one of the router is elected as a designated router, and that router then goes about what they say is creates what they call as a pseudo node, right? So they'll create a pseudo node, which is nothing but, think of it as a virtual router kind of a thing, right? It's just a logical construct. It's not an actual physical router, right? So it will create a pseudo node as such, right? Such that all the 3 routers are connected to it this way, right? So that's what we call as the pseudo node, right? And that is who is creating it? The designated router or the designated intermediate system is the one which is creating it, right? So now how does this really help? Is that right? So now what happens is the pseudo node, which is obviously created by the designated system, basically floods the LSPs which are concerning this whole broadcast segment, right? So he is the one who is going to broadcast it, and he is going to flood, and that flooding generally happens to a multicast address. I'm not sure about the exact address, but the flooding happens, and the pseudo node is the one which is going to flood it. Now, as a result of this, lot of things, right? One thing is, you have drastically reduced the amount of adjacencies or neighborships which you would need. Second thing is, you have also reduced the LSP churn as well, because right now only this guy is the one who is going to flood it, right? And if there is some change in the network, right, of any of the devices, only then those changes are flooded back to the pseudo node, and he will then flood it to the rest of the devices, right? But this kind of a concept is very similar to, I would say, your OSPF, your designated router kind of a concept, right? But the main difference here is you don't call it as a DR, BDR, rather you call it as a designated intermediate system, and that in turn creates something called as a pseudo node, which is then tasked with flooding the LSPs concerned to that particular broadcast segment, right? Cool. So that being said, and that is why I said P5 is the designated router, because you see here it has two LSPs right now. So one of the LSP is its natural LSP or the device LSP, right, which is actually sent by P5 itself, and the other one is the LSP which is created by the pseudo node, right? So this is the P5's pseudo node LSP, which is trying to summarize all the information for that particular broadcast segment. All right, so that's how different your ISIS behaves in a point-to-point network when compared to your broadcast segment. Sweet. All right, so next, what do we do next? Now, right now P5 has formed the designated intermediate system, right? But we can change it. But we can make someone else behave, or we can make someone else take over that role, and that can be done by changing the priority. So what we'll do is we'll make S1 as the as a designated router now. So we'll go inside router, I believe ISIS, go inside lab, right? And we'll have to probably, which is the segment we are talking about, the interface gigabit 0/0/0/4, right? And what else? We will have to go to the circuit level 2, obviously. Let's keep all of that as is, will not change it. Only, yeah, this is the place where you can put the priority. So I'm gonna put a priority of say 100, right, for this guy, and we'll say address family IPv4 unicast, right? So now when I commit this, what happens is, right, your P5, this entry will still remain in the database for some time, but you will start seeing, because you have made S1 as the designated router, you will start seeing the LSP of the pseudo node appearing here, right? So let's look at that. So let's run this one, right? There you see, right, what I told, it's exactly how it is behaving, right? And you can also see, meanwhile, for L3 and L4, it has completely removed the older LSPs. Right now it is, because it is point to point, they are not going to have the whole they're not going to have any duplicate LSPs, or they're not going to have LSPs from the pseudo nodes, right? Earlier L3 and L4 segments were behaving like a broadcast segments, right? That's why they were there. But once I convert them to point, you can see you just have single rows against their names. But the change what I just now did basically brought about this. We have brought about the second row here, which is nothing but the LSP because of the pseudo node with pertaining to the segment S1, S2 and P5. Alright, so I think I think that was kind of clear, I guess, till that point, right? If you can also probably, if you want more details from an interface point of view, you can do show ISIS interface, and the interface we are looking at is gigabit 0/0/0/4, right? I think, yeah, there you go. That should give you more information about that particular segment, right? That broadcast segment, because that's the interface in that segment, right? Sweet. All right, so the next part, what we want to do is, okay, first let's go and disable this whatever I did now, right? Let's go and disable that segment completely, because I'm not going to be using these 3 links. I'm going to quickly go and disable that. So how do I disable? I can shut it down, and then I can do a no interface under ISIS, right? So let's do that on this one. Let's do it on 2, and let's do it on P5. So let's do that on this guy. Sweet. So that's done. So once we do that, in due time, do show ISIS database, right? In due time, after some time, this entry will be removed because because that particular entry is no longer needed because we have disabled ISIS on that broadcast segment. All right, cool. Next. All right, so the next use cases will tinker with the level 1 and level 2, right? So as of now, all my S1, S2, L3, L4, all the 3 guys or all the 4 devices are in level 2 adjacency, right? What I mean by that is if I do, let's do show ISIS neighbors, you can see it's all L2 over here, right? But we never talked about what happens if I use L1. So L1 is generally used for intra area, right? Within the same area. Whereas L2 is used to form neighborships when you want to kind of like talk between different areas, right? And what I mean by that, let me just quickly come down here, maybe use the diagram black. Okay, so imagine we've got like, I don't know, maybe a couple of routers here, we've got a couple of routers here, right? So they are connected, this is connected right now. Because this one, imagine that it's in one area and imagine this one is in a different area like this, right? So generally what kind of configuration goes is we end up creating this one as the L1 adjacency because it is in a in the same area. This one is also going to be L1 between these both, but then you also enable L2 on this guy as well, right? You enable L2 on this guy, you enable L2 on this guy. Why? Because they both have to form L2 adjacency. Only then, the information about this area can be exchanged with this area and vice versa, right? So L1 can be used, or L1 adjacency can be used only within the same area, whereas L2, you generally use it between two different areas. But then the fun part is you can also enable L2 if you want. You can make this guy generally. Okay, so this is probably not a good representation. Let me just erase this one. Because you enable this L1, L2 at the device level, right? So maybe it's better to just call it out this way. So let me just, so this one is L1 right now, this one is L1, right? So here also you have a L1 and here also you have a L1. But the fun part is, it's not that L2, you can enable it only between areas, you can also enable it within the same area as well. So I can have literally multiple adjacency also over here, and that's what we have actually done. We have enabled L2 in the same area, right? Because here you see this is L2 right now. We've got the L2 adjacency here and they are all, this device and this device, both of them are in the same area, right? So ISIS gives you the flexibility to do that. But actually in a proper design, right, what people do is they use L1 in the area, inside the area. And when you want to talk to someone in a different area, that's where, you kind of establish L2 between these both guys, right? And while doing that, what happens is as soon as this router you enable L2 on this guy, let me just erase this part once, right? Let's go back to the older example, right? So where we have just L1 here. So what happens is as soon as you enable this L2 here, this guy will inject, or there will be a default route injected in this guy's routing table, right? So there will be a default route injected, right, saying that you want to go outside, please reach out to L2, right? And same thing happens here as well. Reach out to whatever this router is, maybe R2 or R3, whatever it is, right? So that's the whole idea about your level 1 and level 2, right? But right now in our topology, we have level 2 everywhere, right? We have enabled level 2 everywhere because, because that is technically allowed as well, right? Like I said, you can enable level 2 within the same area as well, right? But now let's go and tinker it, right, to see how it behaves. Okay, so all right. So before we do that, what I'll do is let me go down to the device and let's grab the current show IP route from the devices. Give me a second. Right. So let's quickly go down to the device, and what we'll do is we'll do show route on, I don't know if right. So I just want this output here because I want to show you the difference once we go with the next use case, right? So let's do that on S1, S2 and probably L3 as well. Right, there you go. So this is what we have as of now, right, on S1, S2 and L3. Nothing but these are your normal routes which are learned. You know, you have the L2 routes, you don't see anything L1, everything is L2 routes, right? So on the 3 devices. And now let's go about tinkering this. So what we do is on this L3, let's go and change all the neighborships to level 1. So what I mean is, let me show you. Show run router ISIS. Okay. So right now you see the interface loopback 0 is level 2, interface gigabit 0/0, 0/1. I mean, these two interfaces are not even used, so don't worry about them. But mainly look at these 3 interfaces, right? They are level 2. What I want to do is I want to change them to level 1. So let's quickly do that. So let's grab that. Okay, give me a second over here. Okay, so let's go and so this is the L3 and awesome. So there you go. I'm converting them. I'm gonna commit it, right? But it's not sufficient if I change it only on one side. I will also have to change it on the other side. So I'm doing it on L3. So I'll have to change it on S1 and S2 on this gigabit 0/1 interfaces, right? Because like I said, on one side if it is L1, on the other side it is L2, then the neighborship will not form. So that's why I will have to go and do the same thing on this side as well. So let's do that. Do I have the, give me a second. Yeah, so let's grab that one. And so yeah, so that's the interface. I'm gonna make it level 1, commit, and also on S2, and we'll commit this. Sweet. So once we are done with this, let's check the differences. First thing is, let's go and check what has happened on my L3. Let's do show ISIS neighbors, and you can see the type has changed from L2 to L1, isn't it? Right? So that is one significant change. The other is, let's run, did I run show route here? Yeah. So I've run show route here before. Let's run the same show route here as well. Ah, interesting, isn't it? Look at the size of the routing table now. It's pretty small. You don't have any of the routes, you know, any of the older routes which you were seeing here, right? You don't have those, right? And the reason is because you see all these routes were L2 routes, right? And now because we have changed the adjacency to level 1, it is no longer getting any of those routes, right? So always remember that, you know, the routes, if you want, you will always get the routes which are, if you are in level 1, you will get only the level 1 specific routes, right? The level 1 is not enabled, or it's basically not enabled on any of the interfaces on the neighbor, which is S1 and S2, and as a result of that, you don't see any of the routes here. You just see only the directly connected routes on my own device, right? You don't see anything learned via ISIS. Why? Because if you see here, if I do show, maybe, yeah, do show run router ISIS, right? You see here all these guys, except obviously the interface, right, where the neighborship is formed. All the other networks are all in level 2, right? So none of these routes will be visible on my L3 and L4, or in fact only L3 for now, because, you know, this guy is trying to form level 1 adjacency with S1 and S2, right? But the same thing on my S1, let's see what difference. Do show route, right? So if you see here, not much of a difference, I would say. Only difference I would say is, you can see here the L2 has changed to L1 over here, right? And especially this L3 is nothing but 3.3.3. You can see the route is still there, right? Only the difference is it has changed to L1, right? So always remember the routes flow from L1 to L2 and not vice versa, right? So from L2 to L1 you don't get the routes, which means you know, here in this particular case, you know, S1 is learning about the 3.3 as a L1 route, right? And further, you know, when this guy is sharing that route with some other router, right? Maybe, I don't know, P5 or something, right? Maybe let's check it on this guy, right? Show route, right? So here, when he's sharing it with someone else, it will be shared as a L2 because they have a L2 neighborship. You know, S1 and P5 has a L2 neighborship. But at the same time, the reverse is not true. What I mean by reverse is that, look at this P5. On this P5, we've got the 5.5.5, which is learnt on S1 as a L2 route, right? But this L2 route is not getting learnt on L3, right? Because, like I said, the routes don't flow from L2 to L1, they flow in only one direction, that's only from L1 to L2. So that's very important to understand, right? Cool. So next what do we do is, let's try to, right now all the devices are in the same area, right? So that's why you don't see the default route getting injected, right? You don't have any default route here. But now what we'll do is, let's try to tinker with that, right? So let's move my 3 devices to different areas. So what I'm going to do is, I'm going to right now actually all my full network is in area 1, right? So what I'm going to do now is, I'm going to add area, let's call it as area 3. I'm going to add it to L3 first. So let's do that, right? There you go. So I'm removing my current net ID and I'm adding a new net ID over here, and let's go and commit that, right? So that's the change on L3. Let's do the same change on S1 as well. S1 also I'm going to do the same change, removing the existing, adding a new one, which is, just observe this one, right? Rest everything is same. I'm just changing the area to 3, right? So let's do that. And the other guy, which is S2, let's do that as well, right? So let's do that here and commit. Cool. So now if we go to my L3, right, we should have the default route which I was talking about. So let's do show route, right? There you go. So we've got the default route getting injected here. Why did this default route come? Because, like I said, L3 is connected to S1 via L1 adjacency, right? And S1 is connected to the other networks, which is over here, right? So L3 is connected to S1 using L1 adjacency here, but S1 is connected to other network, which is P5 using L2 adjacency, and S1 and P5, they are in 2 different areas, right? S1 is in area 3, whereas P5 is in area 1, right? So when these 2 conditions satisfy, S1 will say that, look, I am connected to a different area, right? So if you want to get out of the area, do send your packet to me. So that's the reason, you know, a default route is injected into where? Into L3, and that's what you see here, right? And you see two of the paths here because the same thing is happening on S2 as well, right? So we have done the same changes on S2 as well, right? So as a result, now L3 can reach out to the world, reach out to the other areas, right, using either S1 or S2. It's going to do that equal cost, you know, multipath. So that's the concept about, you know, what happens when you tinker with the areas, right? Now let's go a little bit deeper, and what we'll do is, let's do the same change what we did on L3, but let's do it on L4 as well, and let's see how that brings about the change, right? So let's do that. So this is L4. So I'm going to go inside config mode. Let me show you what I have right now. I have run router ISIS, right? So this is what I have right now, right? It's all level 2, level 2, level 2. I'm not happy with level 2, so I'm gonna go and change it to level 1, right? So there you go. And okay, give me a second. Yeah, so let's go and change this to level 1 here. So I'm deleting the existing net ID, right? I'm adding a new net ID, and I'm changing all the guys to level 1. That's done. And let's also go to S1 and S2, right? These both guys, and let's add one more area, right? So you can have multiple areas on the router as well. Right now I have just area 3, right, on S1, S2, because I wanted to put my L3, S1 and S2 all in the same area, which was area 3, but I also want to introduce one more area for my L4. So I'm going to add one more area to S1 and S2, and you'll see the fun happening, right? So let's go and do that. So for area 4, let me just grab that. Give me a second. Alright, so what is this S1 connecting to? S1 is connected to L4 via 0/0/2. Same is true for S2 as well. So this is the same configuration on both the devices. So let's do that. So let's put it on S1 first. Commit. So you see, I've converted that guy to level 1, and I have not deleted the old net ID here, right? I still have the 3, but in addition to that I've added the 4 as well, and the same thing would go here as well. So let's do that. Alright, so we have done that, right? So now let's go to my 4 and see what has happened, right? Do we see the default route? There you go, we've got the default route, right, on this one as well, right? So here as well you get the default route, which is visible over here. Alright, so I had made a small mistake here. When I put the configuration on S2, I had put in 001 here, right, which is same as the system ID of R1, right, or S1. So I had to change that to this one, and then it accepted. So pretty cool. I mean, the router was able to tell me that I made a mistake over here, right? So I think I missed that one. But once I changed it, now if you see, right, the default route on L3, I have equal cost multipathing. This is my S1, this is my S2. So it is basically telling if I want to reach out to other area, I can go via S1 or S2. The same thing is valid here as well. On my L4, if I want to reach out, I can either go via S1 or I can go via S2, right, which is perfect, right? Technically now, the fun thing is, if I want to connect to some device outside, so I'm on L3, do you think I will have reachability to this other end, which is P7? I think I should. So let's try that. So I'm on, let's go to L3 here, and if I do, let's do ping 7.7. Or whatever that is, 8, right? 7, I guess. Okay, 7.7. let's source it from, I don't know, maybe 3.3.3, right? There you go, the connectivity is there. Though 7.7 is not there in my routing table, right? It is not there in my routing table. Still, it will be sent to the default route, which is nothing but my S1 or S2, right? Or I can do a trace route as well. So let's do a trace route here, right? And you can see here, it is now, this time it is taking S1 approach, and then it is going. Maybe next time if I do, probably it might take, okay, it again took S1. But yeah, it will load balance depending on different streams, right? Different flows, it will load balance and it will send either to S1 or S2. Alright, so one last thing which I want to talk here is very interesting, which is leaking between the L1 and L2, right? We learned that routes are flowing from L1 to L2, right? But not the other way around, right? But we can force it, to behave that way, or by default that doesn't work, but you can make it, you can leak the routes from level 2 to level 1, which means, what I mean to say is, in simple terms, right now I have just L1 relationship between L3 and S1, right? But after doing this task, or after doing this exercise, we will, though they have just level 1 relationship, we will still see this level 2 routes, right, getting injected into level 1. As a result, L3 will have those routes in its routing table. So that is what we are trying to do now, right? And this one obviously is not very straightforward. You'll have to do it a little bit with say route policies and so on, right? So what I'm going to do is, let's do this on S1 and S2, right? So let's go to S1. Let's clear the screen a little bit. So what we'll do is, we'll create a prefix set, right? This is how you create a prefix set. We're going to give it a name called loopbacks, and we are going to say any prefix with the mask of equaling to /32, and that is the only, I'm just using this as a identifier to figure out which is the loopback, right? So classify the loopbacks. So I'm creating this as a, what you say, prefix set. Okay, looks like there's already one, but that's fine. So I'm creating a prefix set, and let's create a route policy, right? So I'm creating a route policy, and we'll use this route policy under ISS. Pretty straightforward. So route policy is basically this. It is I'm giving the name loopback, and I'm saying if the destination, right, if the network prefix, right, which basically which is there in my routing table, and which I'm supposed to exchange with someone else, right, if it belongs to this prefix set, right, basically in simple terms what I'm telling is I'm creating a route policy and I'm telling that all the loopbacks, right, which equal to /32, right, please, you know, do something on those, right, take some action on those, and we'll define that action later in the next step. So right now this is only classifying, right? So there you go. So there's already a route policy, so it's giving me this error, but that's fine. Now what we'll do is, like I said, we have classified the loopbacks, right? Basically, when I say loopbacks, what I want to do is I want all these loopbacks of P5, P6, P7, P8, all these loopbacks which are here, right? I want those. They are right now in L2. They are right now in the L2, adjacency or the L2 database, right? L2 LSP database. I want them to move from there to L1. So I have classified them using the route policy. Now let's go and use that route policy inside the Lisp, right? So this is how you do it. You go inside Lisp, you go inside your address family, you say propagate level 2 into level 1, and you then attach that route policy, and there you go. That's it. The same thing needs to go on the other side as well, which is obviously S2 as well, right? So let's commit that. All right, so now once we did that, right, we should see some fun stuff. Let's go back to L3, right? So in my L3, you see this was the routing table before, right? This was the routing table. You see I don't have any loopbacks like 5.5, 6.6 and stuff. But once I do this, since I have leaked now, there you go. See, you can see 5.5, 6.6, 7.7, 8.8, and all of them come with a tag called inter-area routes, right? IA, right? So we have gone against the rule of ISIS, right? And we have used route policies to leak the routes from the level 2 database, right? When I say database, this is what I mean. Show ISIS database, right? So you see there is level 1 and level 2 over here, right? So we have gone against the will of ISIS to leak the routes from your level 2 database into level 1, right? And that is why, because we leaked, and we did not do the leaking here. We did the leaking on S1, right? So once we did the leaking, and since S1 has a level 1 relationship between L3 and L4, you can see those routes now appearing here. Same thing should appear here as well, right? So on L4, if I do show route, mistake, right? You can see here 5.5, 6.6, all of these routes, which were level 2 based routes, they have now been injected or leaked into level 1. Sweet. Okay. The other thing which I also want to cover up, I think that's the last part of this video, would be metric, right? So I talked about metric a little earlier. Let's quickly look. By default, I think, or in my configuration, I'm not sure if I explicitly define. I think I did explicitly define, right? So let's do show run router ISIS. So when I do that, you can see that currently the metric style is metric wide, right? So on all the devices, it is metric style of wide, right? So let's say I go to a router, say L3. Let's clear this screen a bit. So if I do something like, let's look at the route for 7.7.7, right? So right now it is doing equal cost multipathing, which means it is telling me that there are two routes. One is via S1, other one is via S2, right? So it is basically telling to reach 7.7, I can go via two routes. And the reason is because you see the route metric is same, both the places, right? It is 40. You can also see this here, show, the route metrics, you can also see generally here as well. You see the 10 over here, that's nothing but the route metric, right? That's literally the metric of ISIS for that particular path. Anyway, going back here, right? So show route 7.7, it's basically telling the route metric, the total path metric to reach this 7.7 is 40. And since both are equal, it is giving me equal cost multipathing. But what if someone tells you, or someone tells me, Joel, how do I make, how do I kind of prioritize one path over the other? Can you do that? And yes, that can be done as well. So what I can do is I can poison the other route. Like in my case, what I'm going to do is I'm going to poison this other path, which is S2 path via S2, right? I'm going to poison it. How do you poison it? By increasing the metric on that path. So how do you do it? So you go to L3, right? So we are on L3. Let me just grab that config. I think I have it here. Instead of typing, I'm pretty slow with typing. Okay, so I'm on L3. So what you do is you go inside router ISS, you go to that particular interface and you say metric 100. So now you are changing the metric. By default, like I said, every link in ISS has one single metric, irrespective it's a fast interface, slow interface, everyone has one metric, which is metric 10, right? And right now I'm poisoning it. I'm poisoning it by increasing it to 100. I'm gonna commit this guy, right? And obviously I'll have to do it on the other side as well, which is which one? Which is the S2 side as well. So let's do it on S2 here. Same config, nothing different. So now, since I poisoned it, let's go back to L3 and let's check this same output. You see the difference? Earlier, we had two paths because both the paths had the same cost or same metric. Right now, it is just showing one, and that one is only via the 00 and not via this one because we have poisoned the other path. So you can increase the metric that way, right? Or similarly, you can decrease it as well. Increase, decrease, and kind of tinker with it to prefer which path you want your traffic to take, right? Okay, so that was a bunch of use cases which I want to just talk about in this video. Hope you liked it, right? Just to summarize, what we did was we did some bare bone configuration of ISS initially. Then we talked about the difference between point-to-point mode and broadcast mode, right? In broadcast mode, you have the whole idea about designated router, the pseudo node, and pseudo node generating these LSPs and flooding it to the rest of the network, and it is done to obviously reduce the LSP churn, to reduce the adjacencies and so on. So we talked a little bit about that, and then we talked about the difference between level 1 and level 2. What happens, what happens or how the level 1 interacts with level 2, right? The traffic or the routes basically flow from level 1 to level 2 and not the other way around, right? All the routes which are learned because of L2 adjacency, right? They will never be sent to someone with whom you have just level 1 adjacency, right? Whereas the opposite actually happens, right? If you have level 1 adjacency here between L3 and S1, and whenever S1 is learning the routes because of L1 adjacency, it can then forward those routes, right, via L2 adjacency to some other router, which is P5, right? Whereas the reverse is not true. So always remember, L1 to L2, yes, L2 to L1, no. But then if you can override that rule by doing a little bit of what we say route leaking, right, using route policy, what you can do is you can match the routes which you really want to leak, and then you can go under ISS and you can leak those routes. And once we did that, we also checked out one important concept, which is metric. By default, every link in ISS has just one metric, which is metric 10, but you can tinker with it. You can increase it, decrease it, and change the path selection as well, and that would act upon it. The ISS would act upon it, right? So hope you guys liked it.